Now you might be wondering, why on earth are we doing composition functions? What do they have to do with anything? Well, in real world problems, they actually make things a lot easier once we know how to use them. Here it talks about computer animation. You might have read the problem. It says, hey, we have a circle with a radius of 25 pixels. You know, a circle, remember, has upward height, width this way, or height this way, width this way, but it'd be a circle. The animator can increase the radius by 10 pixels per second. It says find the functions and model this data. Well, there's really not that much information here, but here's what you need to know. The radius, and you know what, I'll do a capital R so we don't get mixed up. The radius here, it says, is 25 pixels. But it also says the animator can increase the radius by 10 pixels per second. So I'll do 10 per, we'll say t is for time. This would be referring to our radius. So at 2 seconds, that we started with 25 and it increases 10 at a time. At 2 seconds, we should have 45 because we'd have 2 times 10, which is 20, added to the 25. Now, what we can also find is the area. Now, remember how area equals pi r squared? That's the equation. Well, here's what we're going to do is we're say this radius, this is the function for radius, will go in right there. Just so I'm not confusing people, let me go back to this and have lowercase r. So this r will refer to that. So what does that have to do anything? Well, let's look at this part B. It says find a of r. Now these are capital letters here. What that means is you want to be able to find the area at any particular time. Well, the area is going to equal pi r squared, which means what we're going to do is we plug in that r equation into a. So a of r, and I'm going to go back just so you can see it one more time. This is technically the full way of writing this out, would equal area, which is pi r squared. Remember we had pi r squared. And then we also had that r equals 25 plus 10t. What we would do is we're going to take this equation and plug it in to there. So my equation should look like pi, instead of r, I'm going to replace it with 25 plus 10t, and then that quantity will be squared. This would be my function. Now we could FOIL this out if we wanted to, or we could just leave it like that. But I'm going to go ahead and FOIL it just because we're pre-AP, we can handle that. So we'd have 25 plus 10t times 25 plus 10t. When I FOIL, 25 times 25 is 625, plus 25 times 10t is 250t, plus 10t times 25 is another 250t, and then 10t times 10t is 100t squared. So my formula here, now that I've FOILed that out, and I would need to distribute the pi through, is I would get 625 pi, and remember this goes to 500t, plus 500, I'll do pi t, keep the variable on the outside, plus 100 pi t squared. That would be a of r right there. It might be a lot for you, but that's how animators can use this in the real world. Now you try one.